All right, welcome. This is going to be the beginning of our videos for this course. We're going to cover very briefly the scientific method. The golden rule with these videos is that you try to keep them under 10 minutes, 5 to 10 minutes. So I'll probably be making a few videos for each section we cover. And to start off, in any biology course, the first thing you cover is the scientific method. And you go over general terms like this. What does biology represent, or what is the meaning of it? It means the study of life. Bio refers to life. And it is an approach, and biology is a huge subject. There are so many smaller categories within this big broad term of biology. You have microbiology, ecology, mammalogy. You have comparative plant and animal studying, and you have botany, just all kinds of different categories. Biology is a huge subject, and what we're doing, this is a Gen Bio, we're kind of covering a little bit of everything, and we do so pretty kind of just on the surface. So every lab manual that I've ever used or been associated with, every college, the very first thing you cover is the scientific method. So we're going to start here first. And what does this mean? If you are a biologist and you're going to study something, or you're going to conduct experiments, and you come up with something new, upon your studies, you discover a new organism, you have to follow the scientific method. And that way your results can be reproduced. And you can't just show up at a scientific gathering, or in this case, nowadays you want to apply for things to be published. Well, you can't just say, look, I just found this thing. You have to show the series of steps that you followed. So like it says here, it's kind of a loose guideline for scientific investigation. All right, the very first step, observation description. You're going to look upon something and make observations about it. You might write things down, talk about stuff, but that's one of the very first, the very first part of the scientific method. And that's where you're going to formulate what is called, you start to think about what is called the hypothesis. Now, like it says here, there's nothing to add to this outline at this point. The hypothesis is your question. What are you doing? Why are you studying this? What are you predicting is going to happen? And like it says right there, an explanation or question that is being tested in the experiment. Or if you're just, you're studying a habitat or something, you have to have a hypothesis. The experiment is the part where you're going to then set up your experiment based on your hypothesis, and you're either trying to prove it or disprove it. And like it says there, data that can be used to support, disprove, or modify the hypothesis. So once you do your experiment, like a drug trial, you give people medications. One group gets placebo pills and the other group gets the real drug. At the end of the experiment, you then go through your analysis and see what happened. Did this particular drug help the condition we were testing for or not? But you'd have to do an experiment to get the data for that. Analysis of data is always the part where you get to, and a lot of times, depending on how big the experiment is, that can take a lot of time, but you go through a data analysis, you look and see what all the outcomes are. And then the conclusions. So that's based on the data. Was your hypothesis correct? Or was it not correct? Like it says here, results and conclusions are presented to the scientific community for evaluation. And if the data does not support the hypothesis, then you re-examine everything and you may set up another experiment. Now, we didn't do like a null hypothesis. It can get a little more complicated than this. But I really just, you have to know what are the steps of the scientific method. Observation is the first one. Hypothesis second. Experiment. How else are you going to know, if your question's good or bad? You got to conduct an experiment for that. The analysis of data, and then the conclusions. And to kind of wrap up this last part here, the scientific terms. Now these are kind of interesting. A theory is something that if you've been working independently and you come up with a new scientific something in science, they've determined now there's the law of gravity, there's the law of diffusion. You come up with a new theory. That's what it is, a theory. If your theory can be reproduced, like it says here, can be verified continuously over a period of time, then it becomes a scientific law or principle, like the law of gravity. And like I said, there's the law of diffusion, the laws of osmosis. These are established things. They don't change, and so it's based on that. All right, so let's go to a description. Okay, I wanted to give you an example of how to follow a scientific method using a very simple series of steps. Let's say we were actually in a classroom and there wasn't a pandemic going around. If I was standing in the front of the classroom and I look around and I want to, okay, my experiment would be, who is the tallest person in the room? All right. My observation would be me looking around the room without people standing up, just looking around. And then I would then form my hypothesis. Okay, I think this person in the back left corner, they look like they are the tallest person in this room. That's my hypothesis. John in the back left corner, I believe John is the tallest person in this room. So what comes next is the experiment. So what would you do? Well, you'd have everybody stand up and measure everybody's heights, right? Very simple. I know I'm being very simple here. You measure their height. You decide, okay, what units am I going to use? Am I going to do it in inches, feet, centimeters? Probably would do inches. And then you would measure everyone. Now, the analysis of data would be to go back through and you look at all the data. If there's 20 people in the room, you measured 20 people, you look. Pretty simple. This person is the tallest person in the room. And the conclusion of that would be, was your hypothesis correct? And then if it turns out, no, John in the back was not the tallest person in the room. It was the person on the other side of the room that was taller. So that would be my hypothesis is being rejected. All right, didn't work. Or maybe I was right. Maybe John or whoever in the back corner of that, whoever I wrote down, maybe they are the tallest person in the room, in which case my hypothesis was correct. So that's how it works. I worked in the hospital for 10 years, so I do have some perspective on this. I try to bring that sometimes in biology when I talk, especially in these anatomy and physiology courses. But I was part of a study that involved people that had COPD, chronic obstructive pulmonary disease. And it was an experimental study. Another person wrote it. It was me and two other people. We did the whole study. We did all the testing, the exercise. You had them do pulmonary function exams at the beginning of the study. You then put them into two groups. They were randomized. One group was anaerobic, short-term exercise. The other group was aerobic, long-term exercise. And you had them work out for, and I want to say it was 4 months was the length of the study. Actually it was 6 months. 6 months long of this exercise. And then you did pulmonary function exams at the end, and then you had your conclusion. So you had to now do all the data analysis, and at the very end you formed your conclusion, which I don't exactly remember what the beginning question was. It turned out, which is kind of interesting, that the anaerobic people actually had better gains than the people who were doing aerobic exercise. So that's an example of scientific method. All right, I hope that helps.